All right, in this video here, we're going to talk about some of the special values of the trigonometric functions, right? So we're going to kind of relate some of this this right triangle trigonometry to the unit circle trigonometry that I've done a bunch of videos on in the past, right? So I'm going to start this with a concept from geometry, a 45, 45, 90 triangle, right? So it's a right triangle, it has that 90-degree angle. The two other angles are both 45 degrees. Now, it's a known fact from geometry that if I have a 45, 45, 90 triangle, the sides all have the same ratio, and if the lengths of the two legs of that triangle are 1, the length of the hypotenuse is going to be the square root of 2. Right? If you don't believe me, you can use the Pythagorean Theorem. If you do 1 squared plus 1 squared equals square root of 2 squared, you'll see that those two are actually equal, or you can look it up in a geometry textbook or look it up online to see an explanation of why this is. I'm going to proceed assuming that you've seen this before and that you know this. And if you don't know it, just figure it out if you're interested. Look it up and find how that's true. But it's a known fact from geometry. So what I'm going to do with this 45, 45, 90 triangle is I'm going to basically divide each side by the square root of 2. And the reason I'm doing that is because I want to turn that hypotenuse into a length of 1. Right? So I'm going to do that side, the square root of 2 divided by square root of 2, which is going to give me a 1, right? Because anything divided by itself equals 1. And I'm going to do 1 divided by the square root of 2. I'm going to take these other sides, which are 1, and divide those by the square root of 2. Remember, for the 45, 45, 90 triangle, right, it's a ratio of those sides. It doesn't have to be 1, 1, square root of 2. It could be 3, 3, and then 3 times the square root of 2. Or it could be 7, 7, and then 7 times the square root of 2. Right? It's not like they're always these three numbers exactly. This is the ratio of these three sides to each other. Right? So to keep them in ratio, I'm dividing all of the sides by the square root of 2. Now this one here, 1 divided by the square root of 2, if I rationalize that, I get the square root of 2 over 2. Right? Root 2 times root 2 equals 2. And that should be a number that looks kind of familiar. If you've seen the other videos that I've done on trigonometry and the unit circle, you should recognize this number here. Right, so I'm going to erase what I had up here, and I'm going to change this so the hypotenuse side, when I divided by root 2, I got a 1, and the two 1 sides, when I divided by root 2, both of those became root 2 over 2. All right, so I took that, that 45, 45, 90 triangle. I divided all the sides by the same number to keep them all in ratio. That's why I had to divide them all by the same number, so they keep that same ratio, to force that hypotenuse to have a length of 1. Now the reason I want that hypotenuse to have a length of 1 is because now I can fit that 45, 45, 90 triangle into the unit circle, which is exactly what I'm going to do. Right? So remember the unit circle, and if you haven't watched all the videos I did on the unit circle and the definition of it and the terminal points, those are things that really you should know by now in order to understand what we're talking about here. So if I lay that 45, 45, 90 triangle into the unit circle, so that one of those angles is in standard position, meaning that angle is at the origin, right? So 45, 45, 90, right? The hypotenuse is 1. Remember, the radius of the unit circle is 1, right? That's why I wanted to make this a radius of 1, so that hypotenuse fits in. That hypotenuse is now the radius of that unit circle, because it goes from the center of the circle out to the circle. Right? This side here is root 2 over 2. This side here is root 2 over 2. Right? So this point here on the unit circle, well, that has an x-coordinate now of root 2 over 2. Right? From here, I move to the right, root 2 over 2 units. So that has an x-coordinate of root 2 over 2. And the y-coordinate, I go from the x-axis up to here. That's a distance of root 2 over 2. So the y-coordinate is also root 2 over 2. Right? If you remember what we've done before on the unit circle and some of the other videos I've done, that's one of our terminal points that we should remember from the unit circle. And if you remember your trig hand, right, that's the one that corresponds to the middle finger, right? It's root 2 over 2, root 2 over 2. And that middle finger corresponds to the pi over 4 value. Right? Right? So that pi over 4, now what I'm saying here is an angle measure of pi over 4 corresponds to 45 degrees. Think about it like this. For pi over 4, remember, pi is equal to 180 degrees, right? You should have watched some of the other videos that I did about converting between radians and degrees. If I put in pi as 180 degrees, 180 degrees divided by 4 is 45 degrees, right? So on the unit circle, the terminal point for pi over 4 is the same as the terminal point for 45 degrees because those are the same angle, just in different measures. and the terminal point is root 2 over 2 comma root 2 over 2, and where that comes from is this 45, 45, 90 triangle, right? So when I first did videos on the unit circle, I never really explained where these numbers come from, because at that point, before we do the right triangle stuff, I really can't explain that until you understand some stuff about right triangles. But in this video here, I'm going to kind of show you where those numbers on the unit circle actually came from. So here's the one for pi over 4, which corresponds to 45 degrees, root 2 over 2, comma, root 2 over 2, right? That's why that terminal point is what it is. It comes directly from a 45, 45, 90 triangle placed inside the unit circle, right? I'm going to pause the recording here, and I'm going to erase this one, and then we're going to do something similar with a 30, 60, 90 triangle. All right, so I put up here another known fact from geometry, and again, if you don't remember this or you never learned it, you can look it up somewhere else to confirm that this is true. Right, so if I have a right triangle where the degree measures of the angles are 30 degrees, 60 degrees, 90 degrees, we call it a 30, 60, 90 triangle. The sides of that triangle have the ratio 1 to root 3 to 2, right? So the 1 is opposite the 30 degree angle, the square root of 3 is opposite the 60 degree angle, and the 2 is opposite the 90 degree angle. Now for this one, I'm going to do the same thing that I did with that 45, 45, 90 triangle. I'm going to take all my sides, and once again, I want that hypotenuse to have a length of 1 so that I can fit it inside the unit circle. So if I want that 2 to be a 1, I need to divide it by 2. Right? So I'm going to do 2 divided by 2, I'm going to do 1 divided by 2, and I'm going to do the square root of 3 divided by 2. Right? I'm going to take all the sides of that triangle. Since they're all proportional to each other for any 30, 60, 90 triangle, the sides have these same proportions. Well, I'm going to do it with the one where it's half of this proportion. I'm dividing each one by 2, and that makes that hypotenuse side equal to 1. Right? So that's going to become a 1, and then the one side is going to become 1/2, and the other side is going to become root 3 over 2. And once again, if you remember the stuff from the unit circle, the 1/2 and the root 3 over 2, those numbers should look pretty familiar to you, right? So let's see how this plays out here. All right, so let me draw a unit circle up here real quick, or a root approximation of a unit circle. And let me put this 30, 60, 90 triangle with that hypotenuse of 1 into the unit circle. And once again, I'm going to put it in here so that it's in the angle, the 60 degree angle in this stage is at the standard position. It's at the origin, right? So it's going to go up to here, come down, and back over here. All right, so here's my 60 degree angle, and this is a 1, this is root 3 over 2, and this is 1/2, right? So those are the three sides for that triangle. And again, since the hypotenuse is 1, that becomes the radius of the unit circle. All right, so this point here, this terminal point on the unit circle, well, it has an x-coordinate of 1/2, right? Because when I move over in the x direction, that length of that side of the triangle is 1/2. And then the y-coordinate, when I move up, the length of that side is root 3 over 2. So this terminal point over here has coordinates 1/2 comma root 3 over 2. And once again, it should look familiar from your trig hand if you put down your index finger, right, which corresponds to pi over 3. Right? The terminal point is 1/2 root 3 over 2. Right? That's where that terminal point comes from, is directly from that 30, 60, 90 triangle, and just kind of laying that special triangle into the unit circle. Right? And once again, the pi over 3 now corresponds to the 60 degrees, just like up here before, right? The 45 degrees and the pi over 4 corresponded. And once again, to kind of show you that, pi over 3, right? If I take that pi and replace it with 180 degrees, 180 divided by 3 is 60 degrees, right? So pi over 3 corresponds to 60 degrees, and the terminal point for pi over 3 or for 60 degrees is 1/2 comma root 3 over 2, which we can get from our trig hand. If you haven't seen the videos I did on trig hand, check them out because they're pretty awesome, and they'll show you that stuff. All right, so there's my terminal point for pi over 3 or for a 60 degree angle. Now, using this exact same triangle, we can get the other terminal point from the first quadrant that we've seen before. All right, let me just kind of erase some of this stuff, as much of it as I can, to make a room to draw this next one in here. If I take that same triangle, but I lay it in the unit circle the other way so that the 30 degree angle is in the standard position. All right, so now this is a 30 degree angle. Well, this is still a 1 here, right? The hypotenuse is still a 1. The side that's next to the 30 degree angle is the root 3 over 2. And the side that's next to the other side here would be 1/2 now. So this terminal point here, right, for a 30-degree angle, well, now the x-coordinate is root 3 over 2, right, and the y-coordinate is 1/2, right, which is the terminal point that we learned back when we were doing the unit circle trigonometry. That's the terminal point for pi over 6, right, which is for your, when you put down your ring finger, it's root 3 over 2 for your x, and then 1 over 2, 1/2 for your y. Right, so those two, and that's why those two terminal points for pi over 6 and pi over 3 have the same numbers. They're just switched around. I never really mentioned it in any of the other videos that I did, but it's because they both come from the same right triangle. Right, they both come from a 30, 60, 90 triangle. It's just, when I lay the 30-degree angle here, I get root 3 over 2 comma 1/2. When I flip the triangle around like I had it before and have the 60-degree angle here, I get 1/2 comma root 3 over 2. Right? They're the same numbers because they come from the same triangle. I'm just flipping the triangle around, which is why I switched the x and y coordinates for those two terminal points. Right? So we can see the terminal points that we learned previously on the unit circle, this is where they all come from. Right? And what I'm going to do here is pause the recording and draw up one big unit circle where I kind of go all the way around and like just put all the numbers in place, and also the radian and degree measures for all the angles. Just so you can see some of the patterns there and what the unit circle looks like when you completely fill it out. All right, so I put up here the unit circle with all the radian and degree measures and also the terminal points from just the first quadrant, the ones we just talked about with those special right triangles. Right, so if you watched the other videos that I did about the unit circle before, then you should already be familiar with the stuff that's up here in blue, which are all the radian measures of all the angles. Now, I didn't actually draw the lines for each angle. I did that, but then there was just too much stuff going on, so I erased all the lines in the middle. But like for this 30-degree thing here, or the pi over 6, the angle that forms with the x-axis and then the line that goes through that point right there, that makes a 30-degree angle here at the origin, right? Or the 150 degrees over here, if I take the angle from the x-axis and then the line that goes through that point out here, that makes a 150-degree angle, right? So I just didn't want to draw all those lines. It was just too much stuff on the board here. So all those pi numbers you should be familiar with if you watch the videos I did on the unit circle. And if you didn't see the one that I did on the unit circle and how to see the patterns and how to label these numbers here, you should definitely check that one out, because it definitely helps as far as remembering that this one down here is 4 pi over 3, but this one over here is 5 pi over 3. There are patterns to it that make it easier to see. So if you haven't watched that video, you should definitely check it out. What I wanted to focus on here are the degree measures, because that's what's kind of new, what I haven't done a video on before. So obviously my first angle over here, that's 0 degrees, which corresponds to 0 radians, right? If I don't have any angle at all, it's an angle of 0 degrees. And then as I'm going around the unit circle, the pattern is, I add 30, then 15, then 15, then 30. So it's 0 degrees, and then 30, 45, 60, 90. Right? Between these two I add 30 degrees, between these two I add 15, between these two I add 15, and then between these two I add 30, and then I just keep doing that all the way around. So it's 90, and then 120, 135, 150, 180, right? 30, 15, 15, 30. And then the same thing over here from 180, which is half of the circle corresponding to pi radians, I add 30, 15, 15, 30. So it's 180, 210, 225, 240, 270. Right? And then same thing for the fourth quadrant. I get 300, 315, 330, 360. 360 is the full circle, which corresponds to the 2 pi radians. Right? So, and then for the terminal points, again, I did videos when I talked about the unit circle of how to remember those. We just saw that in this video using the special right triangles. You can also use your trig hand, and then how to reflect those points over to the other quadrants. And I put over here the signs for the x and the y in each quadrant. So you just take these same numbers and reflect them over, and that gives you the terminal points for those other quadrants. I did videos on that, so if you don't know what I'm talking about, you can check those videos out. But you can use unit circle if I want to evaluate a trig function, but my angle is in degrees. Like if I want to find the sine of 225 degrees, well, 225 degrees is the same as 5 pi over 4, so I can do it just like I did for 5 pi over 4. It's just now in degrees instead of radians. Right? You can also use this if you forget the radian measures. Like if I want to find out, well, where is 5 pi over 3 on the unit circle? Well, change 5 pi over 3 into degrees. Doing the method to do that, you'll see it's 300 degrees, and you go, oh, 300 degrees is here. That's where 5 pi over 3 is. All right, so here's the unit circle. I'm going to do another video here where we actually evaluate some of the trig functions in degrees.